Hello, hello. How's it going, everybody? Today, I'm gonna play around with some Reactjs, but not in a target browser endgame as you normally might expect. We're gonna play around with Remotion, and Remotion came out. I think it's actually been a while now. We'll take a look at the repo and see the exact time, but I think it's been a solid year. But what it does is it takes React and uses that to render and then create a video out of. I watched a few people use it when it first came out, and it definitely had a little bit of a when obviously when it first comes out, it's more of a alpha state, I guess you could say. So it did have some little bit of rough edges, but I'm presuming they've cleaned it up, and they've actually added a few other things that I don't think that I'm personally interested in, but might be interesting to y'all. So I think it's time to give it a shot real quick, because I never actually got around to trying it out when it first came out. Like I said, I watched other people use it, but I didn't actually use it myself. So we are going to give it a little bit of a roll today and see what it looks like. Let's hop on over here. We got their website, remotion.dev. Throw a chat here. I think I've got. There we go. I have Streamlabs hooked up, and usually it drops a chat message in there when I start, but it seems like it's delayed. And I don't know if it's a YouTube specific thing, but it'll be like I've been streaming for like 5 or 10 minutes, and then it'll be like, "Hey, this stream has started." Okay. Anyways, Remotion. So you can see the preview here. You take you write some React, and you end up rendering out basically. Oh, there it is. Speaking of which, and it ends up rendering out a bunch of frames as like JPEGs, and you can turn it into an MP4. Oh, audio support is included. Interesting. And then a couple other formats, WebM. But I think my specific use case, I am more interested in MP4. And when this first came out, it was mostly just about this. You write some JSX, React, and you get a video out of it. So here they're taking an image, a logo, and transforming it. Use current frame. Okay, so Remotion would be the sort of like a render loop thing, is what I'm understanding from this. Every frame you get, you can. It's like it's a render. It's a RAF, right? Render React render loop. I thought the acronym was RAF. Request animation frame. That's what it is. Yep. I was like, what is that? Use the acronym, and then you forget what it actually stands for at some point. They've got like a little built-in timeline view timeline scrubber, and I think the new things that they've sort of added since I've looked at it last are this Remotion player and Remotion lambda. We're not going to get into that today at all, but they are pretty interesting, and they start to roll into how they are effectively funding this work. the idea is that you can use it for like small nonprofit or for-profit organization, well, nonprofits or small for-profit organizations. And the expectation is that then you start paying for it if you go above that. It seems like it's sort of an honor system for developer seats, but I presume the case where they actually start to get people to pay without just relying on an honor system is cloud rendering. So the where is it? There's sort of two other pieces to this now: the Remotion player and Remotion Lambda. This creates a video player that renders on demand, which is really an interesting use case. So somebody can literally type in and hit play, and it's gonna like render a video on demand, which is really nifty. I feel like it falls into very specific use cases. Like, I don't think that would be something I would ever personally use or need. But it's kind of cool. And then Remotion Lambda would be, I'm guessing these kind of end up having to go together. The idea being that you need to make a call to a backend to do the render, because you're not going to be rendering client side. Just because that would just, I mean, if somebody's visiting this website on a phone, there's no way that you'd be able to render on the device in any sort of reasonable time. So if you have a backend and serverless being beneficial because it scales theoretically infinitely, you can render your videos on the backend in a serverless environment and serve them effectively on demand, completely customized. So I think there are some very interesting use cases. Like, I could, the one that I think of as somebody who streams, I do overlays, and in overlays people will have transitions. You could have a website that somebody can download a customized transition where you write some React, they can upload a logo or some specific text or what have you, and then they on demand get a completely customized video that they can drop into their scene, and you get a customized transition. So there's definitely use cases for it. I'd be curious how mainstream it is. Like, I don't think it's very specific use cases. But either way, I think it's not a bad thing that there's some level of backing that's pushing this project forward. Theoretically, you can rely on people's free time, but at some point that doesn't scale, especially when you're looking at the scale of large companies using the thing that you're supporting. So to be able to have some funding for the people that are working on this to push it forward, I think is not a negative. Or better said, it's a positive thing. But what we're gonna mostly be just looking at today is Remotion. I think we're gonna essentially just shoot through the quick start, and we got a couple different templates. Interesting. A remix. I think we're gonna shoot through like a quick start, get a video going, and just see what it looks like, and go from there. So we have a few different ways we can spin it up. Oh, here we go. That was interesting. Oh, There's our React 3 fiber. That's kind of nifty. An audiogram. Hello world. Turns text into speech and makes a video. That's kind of interesting as like a explainer tutorial type thing. It's nice to have somebody voice craft like a tutorial video or like a quick explainer. But for like an open source project that is changing quickly, that's difficult to support. And if you could, every time an API or something changes, automatically update the video, kind of an interesting use case. I do use Tailwind in a couple places. I think I might end up just starting with the Tailwind. I don't think I really have a good use case. Oh, hey, look at that. Overlays for video editing software. That's kind of cool. What is Skia? I recognize it, but I don't remember offhand. Skia. 2D graphics library. I could actually see a few different use cases where I'd want like a mix of these. A template for creating, oh, still images. So I don't want a still image. I want the video. We've done 3D things on stream, and like, let's see if this command actually still works. Yeah, we did all those on stream. Those were done with Blender, exported as a GLTF and imported into the overlay. So we have assets. We have done React 3 fiber before. So this definitely fits a couple of our use cases, but I don't think it's anything that I am interested in at the moment. I'm actually going to just try the overlay. I'd be tempted to say Tailwind because I use it in a couple different other projects and am reasonably familiar. But I am actually interested in the overlay, partly as like a scene transition thing, but also for videos. And that's actually part of the reason I'm looking at this, because I'm interested in getting these assets that I can use. So let's give this one a shot. I think I am going to use npm for this. Looks like I can just click it and it copies it for me. I'm guessing it's going to create a folder for me. So I'm going to just run it from the root of the directory where I want to create it from. Yes, we can install. What would I like to name? What would you like to name your video? We'll call it scene transitions. So this is what we can jumpstart the project with a template, and I've basically given it a project or a template. I think I could probably go back to the docs then. So I'm guessing we. Interesting. Okay, so it does need FFmpeg, and I'm not sure how that's going to work on Windows, but we will find out. We're not installing into an existing project, so that's fine. We'll see how this goes. I don't need to create a commit. Failed creating Git repository. Well, that's fine. I don't really need a Git repository. Was that scene transitions, I guess? Yep. Okay, let's go ahead and open it up. Not saying that I'm not going to use Git, but I don't need it to create one for me. I'm perfectly fine just creating it after the fact or what have you. And I kind of wonder if it actually did create a Git repository. I just didn't do the commit. Yeah, just VS Code stuff. Yeah, see, we've got a Git repo. So we need to render a video. We run npm run build. Get started by running npm start. So let's just do start and we'll see what we get. I'm guessing it's going to be something that we need to open up in the browser here. But let's click while this is running. I'm guessing this is going to have to install the binaries and what have you. And it doesn't specifically say anything about version. It did definitely just open up a browser on the side here. We're on localhost 3000. We'll give you a frame number and a blank canvas, and then you can render. So at every like tick of the frame, we can render something different. And a video is a function of images over time. Makes sense. So frames per second, FPS, would be typically a video is 30 or 60 is pretty common that you would see on YouTube. So you'd have effectively 30 images every second, and it's like one of those flip books. You stack a whole bunch of images together and you play them all in order really fast, and you get a video. So get video height, width, how long it's going to be, and frames per second. Yep, here you go. So our total duration is going to be number of frames. So we'll probably do an FPS of 30, I think, for this use case. And duration in frames, if we would want 10 seconds, 10-second video would be 300 frames, 30 times 10. You can define a composition by rendering composition component. Okay. So that's sort of like the root. You can render as many compositions as you like. Interesting. So we have different transformations. And it looks like it's relying on CSS transforms. So what we can do is we set an opacity and a scale, skew, and then I'm presuming that, so these are the built-in CSS ways to do transformations. And then to animate, we make that dynamic. So we're effectively like doing inline style, and we're setting the opacity to a dynamic number that every frame we change. And that's how you get this. Spring animations. And Spring is coming from Remotion, so it's got some things that we can import. Interpolate. what would we use interpolate for? So if we're interpolating between okay. So here we're doing a title, and then we can just set the title in the video, and that component itself is the thing that is considering the current frame. And now we can reuse it multiple times and wrapping it in the sequence component. Duration, and this is from. So I'm presuming these props here are saying we want to do the sequence. We're not setting a from on this first one here that I've got highlighted. So it starts at 0, and that's going from 0 to 40. And this sequence is going from 40 to the end of the video, is what I'm seeing here as far as the props go. They don't have an example of it. From duration of frames, name. You can give a sequence a name. Okay. So it labels it in the timeline. And then a couple other. And we do have a bunch of components here. I don't think we need to worry about those at the moment. We can start, and it's doing a Remotion preview. So once we click over to our localhost that's running right now, we'll get this. We can look at the controls once we jump into it. I don't think there's anything that's going to be too involved here. That if you're familiar with video editing will be unfamiliar. You can render a video using GitHub Action. Interesting. I mean, I guess it makes sense. It's basically a little compute. But if you do want to do it like on demand, they've got that Remotion Lambda that we looked at before. And you can just export the audio, which is nifty. Okay, so let's go ahead and open this up. And it is looping. It looks like it's about 90 frames, so 3 seconds at 30 FPS. If we look at our code here, we have an index and then a root. Kind of feel like you could just combine those, but is the expectation that index is the root? Doesn't really say anything here. Remotion config. You can set the codec. We've got 264 VP8, VP9 ProRes. Oh. Interesting. It's set as codec is set as ProRes, but it's not even listed there. And overlay. So we're doing an absolute fill of our title and text, each of which have a specific style. We are doing styles, and you use memo because they use memo feels a little bit odd. Maybe it's fine, or maybe it makes a difference, but that doesn't feel like it's particularly needed. I mean, the idea is that this is only going to change if these values change, which makes sense, but we're rendering per frame. That probably does make it a little bit more like transportable, but I don't know if it's strictly necessary here. it is using Roboto, which is actually the font that I tend to use. Bold, 80, color and size. So we've got our text here. Disappear before end. So we have an in and we have an out, which is used to set the rotate and out Y. So these are transitions. Spring is coming from an import of Remotion. We are getting the frame and the FPS and the duration in frames. And we're giving that to Spring. So frame would be, so scale is, if we go back to here, we can rewatch it to see. The scale is completely dependent on the number of frames. String scale. Config mass. Interesting. So the config from to duration in frame, duration rest threshold. I'm curious what is no. I'm presuming we're relying on some defaults to determine how it's going from like 0 to full scale. The frame rate, the current frame, mass, the weight of the spring. If you reduce the mass, the animation. Okay. So the mass is what's dictating how fast it comes in, or how fast it scales up, essentially. So if we increased the mass to say 20.5, it will take much longer to spring into place. But you can see we're stacking these animations. So we've increased how long it takes to scale up, and it's scaling up, and it hasn't actually scaled down yet in that spring motion. If we look at animating properties, so this is effectively a graph showing you each frame. What would be the value at each frame? Here we're saying we want to set the opacity to this value, and once it hits frame greater than 60, we will be basically 100% opaque. So it'll not be transparent anymore. And that's what you can see here. Once we hit frame 60, flat line, we're at an opacity equals 1. Now the spring is a little bit more complex because we get a little bit of that spring motion. And this starts to we're almost like into like spring physics at this point. If you look at mass, damping, stiffness, overshoot, clamping, we've created them, we've increased the mass, so it takes much longer to spin or to like get larger. But we could also change the stiffness and damping. So like if we do damping as a number, if we turn, I'm assuming damping of 1 is like the default. So if we do something like this, it's going to be very springy. So here we go up and then we come back down a little bit and we sort of like damp out. If you reduce the damping, it's going to do this a little bit more before it kind of gets into place. So see, so we have some options with the scale. I don't think we're gonna play around with that too much, just because that's a lot. And for the things that you put in a video, you would not want to. You wouldn't want to like play around with that number too much. You say what the default is? Damping. Doesn't say what a default is. And we can also set the stiffness, so we can have it. Damping is how much it decelerates every loop. So if you are bouncing a ball off of the ground, you know, and it's going from here to here, when it hits the ground and bounces back up, it might only bounce up to here and then here and then here. That difference is like the amount that's like the damping. It's slowly, the loop slowly gets smaller. And then the stiffness would be how actually bouncy it is. So if we take off this, we leave the damping the same, and we reduce the stiffness, it'll be bouncy, but it's still going to, the bounciness is going to be reduced. Bass stiffness. And I kind of wish they would have so this is real stiff, so you don't get the like that sound effect. Is that a good representative sound effect of the spring? So this is the default. We get a little bit of a pop. When we had the stiffness be 10, I don't know why I capitalized that on me. If we bump the stiffness up to 10, it kind of just goes and sticks. This is real stiff now. So this would be like the difference between like the little spring that you have in a pen or the spring that you have in your car for the shocks. Those are way more stiff because they need to support a much heavier thing. And if they were as soft as the spring that you have in a pen, the car would effectively crush it. So it's all sort of relative too. So these, depending on what mass you do, it's gonna be relative to the stiffness value here too. So if we just go down to like 0.5 maybe. Kind of wish it had the defaults in that. So that makes it real slow. So those are things we can play around with the spring. You can see here they actually changed the damping too. And that is okay, so they're doing an out. And based off of the out, they're doing a spring transition again, which probably isn't needed. It's almost linear in this situation. But we're doing both a rotate and an out. In the rotate, if we save that, let's go ahead and look at the out animation. I don't see the rotation. There's a rotate and a translate. Yeah, I don't see the rotation happening. It might be very subtle. Yeah. Just a very subtle turn. And those kind of like little animation type things are what really sell an interaction. It's one thing to like fade in and out, but something like this is much more satisfying than like just a fade in and out. Okay. So this then ends up being, we're doing an overlay. The overlay has a current frame and then a duration in FPS. From that duration, we are doing it out and making sure that it disappears 20 frames before the end. And we are rendering this whole overlay in the root. So we could potentially do a second composition here and say width is 1000. And I'm not sure what, okay, we need different IDs. That makes sense. We do have the duration in frames of 75. Oh, we can do new compositions here. Interesting. And a color picker. That's handy. So I don't know where it would, if we've got multiple, it says we can do multiple compositions, right? Got playback rate, mark in and out. Oh, that's kind of nifty. So we can do a rich timeline, which would show you all the different elements, it looks like. Let's go back to the composition real quick. I want to see what, here, we're going to close this. Let's start looking at the actual like API docs now. If we look at composition, so a composition is effectively one-to-one in a video I'm reading. Make it show up in the sidebar. Okay. Ah, there is a sidebar. Okay, so we get two. We can actually do two compositions at the same time. We could do a horizontal and a vertical, which is pretty sweet. So like if we were looking for a transition to, that would be useful, or if we wanted to make an overlay and have that overlay transition be useful for both, you know, say a YouTube video or a YouTube short, we could do multiple compositions. This might get a little bit more complex because this the frame is actually smaller, so then we start having to worry about positioning. Here we're positioning it from the right and top 90 pixels. But the benefit of doing this with and using CSS is that, stop looking at that, please. The benefit of using CSS is it's very good at being dynamic. When you're rendering a web page, you need to be able to render on desktop of many different shapes and sizes, and on mobile. So we're going from primarily vertical to primarily horizontal, and we can use that ecosystem. Every stream, I swear. Okay, so if we have overlay horizontal, rather than just frustrating me. Come on. I don't even know if you can see it. No, not really. I guess the lighting's good enough that it still is fine, but I see it in the out of the corner of my eye, off the camera, which just really bothers me. Can you say hi, Bamboo? So if we do a horizontal and a vertical, I'm guessing these IDs are what, dictate which one it shows up here. So if we go here, now we go here. Scale wise, this is effectively a rotation, so scale wise they're going to be the same. But we can effectively end up creating something where we do effectively the same code once, keeping in mind a little bit of the responsiveness a little bit, and have effectively 2 videos that come out of this, which is really nifty. So what? And actually, I just had a real nifty idea too. There is, so this is all CSS transitions. We're doing the use case for this might be a situation where you're doing transitions for video. Chrome, I believe, has an experimental page transition. I think Jake Archibald did a this might be it. It's a demo video. Talk. That hasn't been touched in a while. Clearly they've been working on it for some time. Yeah. It's been a thing I think that people have been interested in for some time. Here's Spa View transitions. Oh. Yeah. You could potentially do a transition that works both in Remotion but also on your website and keep it all the same, which is kind of cool to think about. That might be a little bit extra effort to deal with, but it's cool to think about. Can you say hi? No, we're shy. Okay. So let's see if we can drop in a couple pieces of text. So I don't know if you can hear her purring. Can you see hi, Bamboo? Nope, nothing. No. She used to do that on stream. I would say hi, and then she says she would meow. Now we just want attention. What else do we have? What's this delay render? It should not be immediately rendered and should instead wait. Oh, interesting. Interesting. That makes sense. Based on return how long it takes for okay. So we can tell basically when we were talking about spring animations, we were saying that it does this, and there's some level of damping where it slowly goes down, and if you drop a bouncy ball, eventually it's going to stop moving. That bounce is going to get so small where it stops. When you're doing physics in like a physics engine, you could theoretically represent those incredibly minuscule amounts to infinity. But that doesn't make sense because that's not what actually happens in the real world. At some point, it's just the amount difference that it's so small, we start to get into like, you know, like quantum level physics, that kind of stuff, where from what we can tell, it's effectively not moving anymore. And maybe it is still moving at a very small, minuscule amount or at a quantum level, but at some point, all of that just balances out and it's not moving. Ish. Theoretically, everything's always moving, but it's always like a point of view thing. Either way, physics is everything that we do with physics and physics animations, type animations, and physics engines. It is representative of what we see in the real world. So there's always some of these, like, based on the code, theoretically a spring animation could never end and have tiny movements. But to make it kind of match what we see in the real world, we can put a check that basically says once we hit like a minimum, once we hit a threshold of like the distance that it's actually bouncing, just assume that it's stopped and just stop the thing from moving. But where this would be useful is we can, from measure spring and a config passed in, we can understand like at what frame would this thing stop moving. So we can animate a thing in, and then after it's done animating, animate it back out. Which is interesting because if we want to do text, say give it a sentence and every word animates in and then animates back out, we could effectively render a component on a loop with a spring, and based on the number of characters, set maybe a spring damping or something like that that determines the amount of time it takes to animate in. And once that animation has stopped via the measure spring, we would be able to tell at what frame we can start animating it back out to then animate the next one back in. What else do we have? Loop. So we can loop a thing. Oh, they're already on 2.5. Oh, slight distraction here. So they're on version 3 actually. And I am curious. Usually when you're looking at so they got a little bit of an eclectic license here, and a few projects have sort of moved to this type of copyright. There's upsides and downsides of this. Usually with a non-standard license, it becomes more difficult for a company to contribute, or individuals to be able to contribute, or a company to actually use it. But the fact that they're effectively selling licenses, that makes that situation easier for companies, at least. There's definitely upsides and downsides to it. But what I wanted to look at was 3 years ago. So it looks like it's 3 years old already. Holy cow. Wow, does time fly. Okay. So we got loop, image, off-thread video. Okay, so it does some FFmpeg work, and effectively we're bringing in a video as images, essentially. So there's two. Wow, they've got a lot of motion canvas rendering on the edge. Interesting. Okay, so the video is an HTML5 video element. And I'm presuming what we're doing is when we do a render, we're like rendering in some sort of context, and then from the sounds of it, we are rendering it in Chrome. And that Chrome instance is making something that we can like output as a screenshot, and we're doing that for every frame, and then we stitch it all together with FFmpeg into a video. So I think that's when you bring in a video, that is an additional extra like lift for the browser to render. So I wonder if with the way you would use this video tag, that's when it starts to get into the situation where embedding the video directly is going to make it difficult to render, in which case they have added this off-thread video where you're using FFmpeg to extract images, and then we're showing one image per frame in your video that you're outputting. Oh, we were not on that before. Ah, okay. I don't think there's too much else here. We can freeze frame for a couple frames. That's kind of nifty. So this would say at some point we're just going to freeze it and it's going to stay. I don't see, I mean, there's probably a specific use case for it, but can't think of anything offhand that would be useful for me. Still would be, so we can put in like a just standard piece of text. Actually, this might be useful for, so there's a couple things that I would like to have like rotating maybe down on the bottom there that or animates in and then animates out and comes back around, but it doesn't make sense to do that necessarily as a browser source, because every time you do a browser source in OBS, the program that I'm using to do the stream, and recordings, browser sources, they need to render that source. And if you're doing anything complex, especially something like, that's WebGL. That's not particularly easy to render relative to other things. What we could do is we could set up some stuff in Remotion, export it as a video, and I could use that video on a loop and have like stuff that pops up. So like we could have a thing that says, hey, maybe down here be like, hey, yeah, you that's watching the video right now, yeah. Type in !drop. And like we could do a like rotating thing that says, these are commands that you could use. And I think that'll help everybody. There's not a good yeah, there we go. Thanks, John. And it actually does filtering too, I think. So if you do like !drop star or stars, I think both work. It'll just drop the stars. But unless I literally do it on stream or somebody knows about it beforehand, even if somebody knows about it and watches the stream, it's not necessarily something that you think to do every stream. So having something that is rotating on the bottom that tells people about these integrations that we've done on stream would be nifty. All of that being said, where was I going with that? I guess like that would be potentially some of the duration of frame. So like there might be a piece of text that I just want to like leave there. And that I think would be where still would be useful. I could have an image or a piece of text just show up on the video the whole time. And then I don't have to mess around with like trying to get it to show up in every frame of a video. I can just use this still component. What's the easing? That's not a... Okay, you can use it with the Interpolate API. Got it. Got it. Okay. In... Where's this? Interpolate. Interpolate colors. Oh, that's nifty. So interpolate would be if we know we want this thing to be at x equals 0, and then at frame 30, x equals 30, interpolate would be able to calculate all the positions in between. So we don't have to say this needs to be at position x equals 1 at frame 1, position x equals 2 at frame 2. We can do this interpolation where we feed it in a frame and then I guess give it a bunch of arrays that dictate those values in between basically the start and the stop, which in this case it looks like what is the API for this? Options, easing, params, the range of values that I expect. I feel like that could be more helpful. If you've done anything with D3.js and interpolation, it feels very much the same. And effectively what we're saying here is we're giving it a frame and we're saying from 0 to 20 we want to interpolate between 0 and 1. So at frame 10 we'd be at 0.5. And what's interesting is we've got a whole bunch of extra. It looks like you can do an array of as many things as you want. So a linear interpolation would be if you're going from frame 1 to 30, 0 to 30, a linear interpolation would be that exactly halfway through you'd be so at frame 15 you'd be at, from 0 to 15 you'd be at 15 as well. And that's where these easings come into place. They come into play. Here you can see the linear, but then we have other like do we show any easings.net? Yeah, this is, I think I've been on this before. Do we have an example? Ah, okay, there we go. It's like, that road is not linear. What are you trying to show me? So this is a cubic. So you can see the bottom one right here. That's linear. And the top one is cubic. So it sort of like increases in speed. It's like a exponential almost-ish. It's not quite exponential, but it speeds up towards the end. And that would affect the interpolation because a linear would be straight across. So at x of a value, you get t of a value. But your t increases as, or your x increases as t increases. But t increases at a faster rate. These visuals always, I feel like it's difficult to just explain it or read it in text, but these visuals are always very helpful. Easings.net. I feel like I've been on this before. But they explain a lot of these, and if you do any type of animation, the visual of it is always very appreciated. And once you kind of understand how to like read this, you don't need to test it every time. Like ease and bounce, that gives you a little bit of a spring kind of function. Ease in and out elastic. And they've got this little animation here too. So, we can use Interpolate to move stuff around. What time are we at? We're at about an hour right now. Let's try. We've talked about this Interpolate a little bit. We are using it here. Let's try. It's an Interpolate colors, right? Yeah. Let's try a quick color change here. And I think that's going to be about what we're going to call it for today. We've gone through, and I think we've sort of hit on everything within the Remotion API. Tweening. Is there a difference between interpolating and tweening? I think it's in the same vein, but I think there is a difference. Tweening versus interpolation. Tween and interpolation. Okay, so the area between is tween frames. Oh, also is blanks between keyframes is called interpolation. Ah, okay. So you're interpolating between values. One of those values in between is called a tween. So they're kind of the same, but they've got a little bit of a different meaning and a little bit of a different use case. So the function that you're doing to calculate at each tween is interpolation. Color. We are taking a frame and we're going from frame 0 to 20. So at frame 20, it's going to be completely yellow. And if we do the color, background color, let's change the background color. There we go. So we can say if we slow this down just a little bit so we can see sort of these. Starts out red, transitions to yellow, and at frame 20, do we have down here we have a counter. Yeah, there we go. So we can see once this hits 20, we are yellow. We stay yellow the rest of the time. And it seems like this takes an array. So we could say 40, and I think we go up to like 75. So if we go up to 60, we can now say red, yellow, green, and blue. And these are interpolate colors is a little bit of a special situation because you can give it, it's returning RGB. So what's the difference between red and yellow? We need to, we can use the term we just looked up, a tween in between there. We can't just use text. We can't say what's in between red and yellow, the text. So this function, I'm presuming, is taking these word inputs, converting them to RGB, and then you can do color math effectively to find what a tween would be in between them. D3.js also has a bunch of this functionality. I'm a little bit curious what they're actually using for it. I don't see any links to anywhere. I'm presuming they're using a library because a lot of this math has been established for some time, and I'm guessing it didn't make sense for them to like recreate those functions. Maybe, but. So now we've got 4 like breakpoints effectively. We're giving it a frame. Frame refers to the breakpoints. Then we're going to return these values at each of those breakpoints, and we're going to have values tweened in between. We're going to interpolate between, and it's going to give us interpolate between, and that is going to give us a tween at each frame. Let's hope I actually am using that correctly. That would be somewhat ironic if I'm not. Did I save? I did not save. Yellow, green, and then it'll just turn blue right at the end there. And then it fades out. There we go. So with a combination of interpolate and interpolate colors, we can, and it's less using built-in CSS transitions and more setting CSS like static values. When you're rendering and doing animation with CSS in a web page, you don't have a frame counter. So we would say we're gonna do a transition from here to here, or like you click on a button and it's gonna do it. The transition is gonna do the spring animation. It doesn't have. It uses like a request animation frame, and I think CSS. If you do it purely CSS, no JavaScript, I think it's using something similar in the backend, or like behind the scenes. But we're not using those APIs here because we get frame counters effectively. So we're literally just setting like where it is on the page. So we could actually do something where we say, we can straight up add the frames to it. And this is actually going to transition it in and just keep moving it down frame by frame until it gets animated out. And now our canvas is, in this case, we're looking at a vertical canvas. Our vertical canvas is 1900. So if we bump this up times 10, we've got, right now we're rendering 75 frames. That would make it a little bit more apparent. So we can see it's transitioning down for each, and we can speed it up to real time here. But that also affects our transition out, because our transition out was just moving it off of our actual like viewable area, which was effectively hard-coded to 90. So if we would want to adjust for that, we'd also have to take in we'd have to take this into account. So we could do something like duration in frames times 10. That'll be the translate duration. Oh, okay. No, this will be. But we only want to do it for the last frame. Here, okay. This would be, if we're doing it right there, we're applying it to every, the same value to every frame. But we actually want to interpolate from 0 to -500, which would be off the page. So we're going to do this. So this will do an interpolation between 0 to -500 minus the frames that we've added in this adjustment here. Zoop. There we go. I think this is pretty nifty. I think I got some potential use cases for it. right here up front. Little spinner down here that says, hey, use some of the chat functions. Gonna also have other loops like callbacks, like and subscribe, those kind of things. So I don't have to remember to always say them. I think it's pretty nifty. Specifically for this like overlay, I'll put this little video file I can use in OBS. I could use it in DaVinci Resolve for video editing. I could also see it being useful in open source situations where you want to have an explainer video that updates more dynamically than somebody having to recreate it every time an API or something changes. A little bit less of a human touch there, upsides and downsides. Pretty nifty though. I think that's what we're gonna call it today though. I can't think of anything else that's worth going over, and we about hit our time. A little bit of a short stream. But next time, what are we gonna do next time? It looks like they wrote their own math stuff. Okay, so you looked into it. Interesting. That's an interesting choice. I wonder if it's potentially a dependency. You looked at the core. I wonder if it's like a dependency. They didn't need all the features of some of the other libraries, so they did their own stuff. I think it's rather established math to where you can Google for it and just get the actual math to like figure it out. I haven't actually looked into it myself though. I don't think it's incredibly involved though. But either way, next time, I'm not sure what we're gonna do next time. I do want to do some Tori stuff again here pretty soon. I know I was talking with Jonas, and the last time we streamed, we did Android on Windows. I kind of would like to do iOS on Mac because iOS is a little bit further along, and that might be interesting to do some more of the advanced stuff. But I'm not sure when we are going to do that. So, if you have any suggestions, anything we should look at, anything within, I mean, honestly, anything in the reasonable sphere of things that I've streamed on. We've done 3D stuff, we've done a lot of web, Node. Have we used Dino? I don't remember if we used Dino yet. Done a bunch of Rust and Tori. If you have any suggestions, drop them in the comments below. Otherwise, hit that subscribe button, and I will see you next time. Tuesday at 11 Eastern. Same time, same place. Have a good rest of the week. Bye.